The problem that we're solving is someone else is sitting in my chair. The target audience for this is everyone, because everyone sits in a chair and doesn't want other people sitting in their chair.
This problem is solved when the owner of the chair presses a button on the remote and the incorrect person who's sitting in the chair falls over the chair.
Oh, I'm doing homework. Oh, I'm enjoying my seat. Oh, shoot. I must go to the bathroom. Hopefully no one takes my seat. This is the best homework. I've been so efficient. This has been great.
Wow. This is really an awesome spot to do homework. Wow, this chair. This is probably the most comfortable chair I've seen in my life. Don't mind if I do. Hopefully no one's sitting in here. It doesn't matter. It's not like they have a piston on this chair and they're going to be able to kick me out of it. Finders keepers, losers weepers.
Oh no! I want to do homework.
Dude,
how dare you?
You move your feet, you lose your seat,
Use my
pal.
computer? What the heck? Die.
Here is our piston chair. We have a piston connected to a solenoid right here. Solenoid is connected to an air compressor. And then in this Tupperware container, we have all the power. We have a transistor, and we have an IR sensor right here that takes an input from here. And the transistor in there is basically splitting power between the Arduino and the solenoid because they need different power sources. Anyways, as you can see, when I press the power button, that extends. And when you press any other button, it disarms. So that's basically the whole point of our chair, is you can control the solenoid with this IR remote. And that's about it in terms of what's going on mechanically.
Hello, this is the Piston Chair project by Skylar Iman, Ethan Baker, and Ethan Spiegel. So basically, the basic overview is that the chair is it receives an IR command using the IR remote. So it takes this IR receiver, and then the Arduino interprets that signal, and then it decides what to do next. So on the remote, if you press the power button, then it sends a signal to this control solenoid valve, and then that allows the pneumatic piston to extend. And if you press anything else, it's going to retract the piston, so only the power button will activate it. So this is the system diagram, basically what the code's doing, what it's doing to figure out what needs to happen. So first, configure all the pins, and it's going to start with the LED off and the solenoid closed because it has a light to basically indicate when it's on, just for simplicity, so you know when it's on and not. So then it's going to check if there's an IR command sent, and then it's going to check what that command was sent. So let's say that it wasn't the power button. Let's say it was something else. It's going to go this way, and it's going to say the solenoid is closed. LED's off, don't do anything. But if the power button is pressed, first it's going to turn the LED on, and it's also going to open the solenoid valve. And then after it does those two things, it's going to check for any new commands. So it goes right back to checking commands. Basically, it's just an endless loop of checking commands and seeing if it's the power button or if it's another button, and then deciding whether to turn on the solenoid and the LED or to close the solenoid and turn off the LED. So this is the code. It's basically doing the exact same thing that I just showed. So right here, it's basically checking for a command and reading the command. And then here, if it's 69, which is the number for the power button, if it's pressed, then trigger the solenoid and turn the LED on. So turn off the solenoid so that light goes or air goes into it, and turn on the LED light, and else. So if anything other than the power button is pressed, turn off the light and turn on the solenoid so no air goes through it. And then just wait for the next signal is what this is doing. So here's the circuit diagram. It's pretty simple. Essentially we have, this is the LED light right now, just connected to ground and the pins. And then this is the 9-volt battery that's powering the Arduino. Here's the IR receiver. And then this is the 12-volt battery that is powering the solenoid valve. So the solenoid valve has a 12-volt and a ground. And so the 12-volt goes directly into that. And then we have the grounds of the Arduino this power source and the ground of the solenoid going into this MOSFET transistor, which then goes into port number 5. So the transistor is allowing the two different powers to be on two different circuits. And that's about it. Thank you.